This is R.D. Sharma solution, class 12, chapter 10. Differentiability exercise is 10.1. Find the values of a and b if the function f defined by this is differentiable at x equals 1. So we have x at 1 we have to check. We have a and b, these are two different constants that we have to find out. So we need to have at least two equations in order to get a and b. That is two variables or two values to be found out, two equations have to be there. So what we'll do, we'll start with the continuity. So left hand limit, right hand limit we are going to find out. So this is x equals to 1. And we just go a bit behind or backwards and a bit forward. So x tends to 1 minus, x tends to 1 plus will do. So we have to use the function x square plus 3x plus a when we are just going backwards to 1, and this function, and when we go just ahead of 1 we have to use bx plus 2. That is the only thing which you need to keep in your mind. So limit x tends to 1, we have to use bx plus 2 here. So apply this x as 1 here, 1 square plus 3 into 1 plus a. So 1 plus 3 plus a, it is going to be a plus 4 or 4 plus a. Bx plus 2, so b into 1 plus 2, that is going to be b plus 2. Now these two are equal, so we'll get one equation with this. A plus 4 equals b plus 2, because this is already, it is given that it is differentiable. When it is differentiable, it will be continuous also. So a plus 4 equals b plus 2, and we'll deal it with later, because ultimately we have to put a as b minus 2 in our next step. But the main equation is this, the first equation. Now we have checked for the continuity, we got the one equation. Now we'll go for the differentiability. So let me just clear it up, and we'll be discussing the differentiability here. In order to get the differentiability, left hand derivative and right hand derivative, that is what we are going to find out. And the formula remains the same, fx minus fc. C is 1 here, that is the constant at which we have to check the differentiability. So I'm writing directly f1 divided by x minus c, that is x minus 1. So left hand derivative, x tends to 1 minus, and then this is x square plus 3x plus a. This function you have to use because you are on the left of 1, and minus f1. I'll just tell you what f1 is. X minus 1 in the denominator. Here also same thing, the x minus 1 in the denominator. The function will change because you are now ahead of 1. So you are above 1, for that you have to use bx plus 2. So let us just write bx plus 2 here. And what is f1? Please remember, we have to use where x is equal to 1, and here x is equal to 1. X is less than equal to 1, that is x is equal to 1 also is given. Just put x as 1 here. So 1 square plus 3 into 1 plus a. You get 1 plus 3 plus a, that is going to be a plus 4. So just write a plus 4 or 4 plus a here. Here also a plus 4 or 4 plus a here. So let us solve the numerator first. X square plus 3a plus a plus minus 4 minus a. Now here this a gets cancelled. X square plus 3x minus 4. So we can get the factors here. You can write x square plus 4x minus x. This will be 3x minus 4. X you can take common, x plus 4 minus 1 you can take common, x plus 4 it will be. And it will be x minus 1 into x plus 4 in the numerator. And denominator you have already x minus 1. You can just cancel these two out. Please remember, limit x tends to 1 is always there. I'm not just writing it just to save the time, but it is already there. So x plus 4 in the numerator. Now apply the limit, x tends to 1. So 4 plus 1 is going to be 5. This is your left hand limit, 5. Coming to the right hand limit, let us see what we get. So we have bx plus 2 plus minus 4 minus a. So bx plus 2 minus 4 minus a, what do you get? You have to have some x minus 1. Because x minus 1 in the denominator, as in the left hand derivative, we cancel the x minus 1 with the x minus 1, finding out the factors. Here also we have to find something in the numerator so that we can cancel it out using x minus 1. So as I said, we have to use a equals b minus 2 or a minus b plus 2. Replace this a as b minus 2. So bx minus 2, in place of a, just write b minus 2. So what do you get? Bx minus 2 minus b plus 2. 2 gets cancelled. Now you can take b common from here. X minus 1 will be there. In the denominator you have x minus 1. Now you can just cancel. Please remember, limit x tends to 1 is always there. I'm just not writing it, but it is always there. Cancel these two out, you get b. So when you see that the question is saying differentiability is there at x equals to 1, so b equals 5. And what is a? B minus 2. So you can just put b as 5, a will be equal to 5 minus 2, that is going to be 3. So a is 3, b is 5, for this function to be differentiable at x equals to 1. Now this question is actually in your exercise. It is 7th or the 8th question, but it needs some discussion. That's why I am explaining it in the last, because this function is we have to check for the continuity for the differentiability at certain values. So first we will do the continuity, then the differentiability. The continuity result I'll show it to you. The differentiability result I'll show it to you. Then we'll find out what is this m. M is below 0, m is between 0 and 1, and m is greater than 1. So there are three intervals for this function where you have to tell or show whether they are differentiable, whether they are continuous or not. So all things will remain same, and you will have the expression for continuity, you will have the expression for differentiability, right? So this left hand limit and right hand limit, let us find it out. Left hand limit and right hand limit. So x equals, because we have to check at 0, 0 minus h you have to put. Here you have to put x equals 0 plus h. Please remember, I am telling you about the continuity right now. So x is not equal to 0. What you are going to replace? X raised m sine 1 by x. That will do in the differentiability also. Here equals x equals 0 minus h. You can always write it as negative h. So limit h tends to 0. Now please remember and please stick that into your mind. Always limit h tends to 0 is there. I'm not going to write it again and again just to save the time. But it is always there. So this function x m sine 1 by x, I'm replacing x by 0 minus h, which is minus h only. Here also right hand limit, what we are going to do, limit h tends to 0, x raised m, 0 plus h raised to m, sine 1 by 0 plus h is h only. Now this is negative h to the power m, and sine, see this is negative, sine minus theta is what? Sine minus theta is minus sine theta. Cos minus theta is plus cos theta, but sine minus theta is minus sine theta. So let us take a negative outside, it will be sine 1 by h. Here also, limit h tends to 0 goes everywhere. It has to be written with every step. Remember, h raised to m, I am doing LHL and RHL same time. H raised to m sine 1 by h. So we have to check for the continuity, we have to check for the differentiability. Okay. Now what we'll do here is we can make it easier, or we can directly do it. So m between 0 and 1, because continuity is asked in the second part and third part. So we'll do the continuity with m between 0 and 1 and between m which is less than or equal to 0. So continuity will check at 2 points. Okay. Continuity 2 points we are going to check. So this is m between 0 and 1. We can make this function or the value which we have found more easier. I'll just tell you how, because when the LHL and RHL are almost equal, we don't have to do 2 steps, check for LHL and RHL. We can just do it for both of them. I'll just tell you how to do this. Minus h to the power m. See, minus h can be written as minus 1 into h. Minus x can be written as minus 1 into x, same way. So it is simply equal to minus 1 to the power m, h to the power m. That is a into b to the power m is a raised m and b raised m. And when we have x raised a, x raised b, that is x raised a plus b. So I'm just writing it again. minus 1 to the power m plus 1, because minus 1 we have taken out from minus h. Minus was already there, so minus 1 to the power m plus 1, and h to the power m will be there, and sine 1 by h. So why we have done this? Because the left hand limit and right hand limit, the value need to be, if we get it same, we don't have to do it twice. I hope you got the idea. Because this m is not going to affect at all, because we will be discussing only about h raised to power m. That is going to affect, because limit h tends to 0. It is not limit m tends to 0. It is limit h tends to 0. So m is between 0 to 1. So if you take m as 0.5, say half. So what will be h? H will be 0 to the power 0.5. Minus 1 to the power m plus 1 on the left hand limit. M is 1.5. M is 0.5 and plus 1 is 1.5. But don't worry about that. Just concentrate on h raised to the power m. So this is 0 to the power something, which is 0.5, which is positive. So under root 0.5 is 1 by 2. That is under root 0. Under root 0 is 0. So left hand side will be 0. Here also h is, as I said, it can be between some 0 and 1. So this 0 to the power 1 by 3, I am taking now a different example. Means half I already showed you. You will just ask, why are you not taking 1 by 3, 1 by 4, 1 by 5? So just take 1 by 3. So 0 to the power 1 by 3 is third root of 0. That is also 0. So whatever is there after this, sine 1 by h, whatever is there, it will be 0. Now sine 1 by h is already there. Minus 1 to the power 1.5 is also there. M plus 1 you can just write. That doesn't matter. Why? Because sine 1 by h, the value is between minus 1 to 1. So multiplied by 0 with any of it, it is going to give you 0. So the left hand limit and right hand limit are equal. That means the function is continuous when m is between 0 and 1. Got it? You will understand more when we just check this one. Now m is less than or equal to 0, because the continuity is asked in the third part also. Same thing, I am just taking this function which we just made. So this function has to be used for continuity everywhere. Okay, m is less than or equal to 0. Now just take m which is less than or equal to 0, but you have to check for m equal to 0 also and less than or equal to 0 also. You cannot just check for only m value of m which is less than 0, because it is less than or equal to 0. You have to check for 0 also. Okay. So I'm just putting m as, say, I'm replacing, because we are checking m less than or equal to 0. Now this is the third part we are checking. I'm taking, say, m as minus 1. Here also same thing, h raised to the power minus 1. I'm taking m as minus 1 because we have to take something less than or equal to 0. So second case already been done. Now I am showing you the third part. Please remember, this is the third part. For second part, we have already proved 0 equal to 0. So this is h raised minus 1 sine 1 by h. H raised minus 1 is what? X to the power minus 1 is what? 1 by x. So you can write, I'm not dealing with minus 1 to the power m plus 1 and sine 1 by h. This is h raised to power minus 1. You can just write it as 1 by h. This also, h raised minus 1 is 1 by h. So this is 1 by h. Whatever is there, it doesn't matter, because we know 1 by h is what? Now 1 by h, since h tends to 0, limit h tends to 0, when you take and limit h tends to 0, here also limit h, as I said, limit h tends to 0 is in all the step. 1 by h is 1 by 0. 1 by 0 is infinite, it is not defined. So this is not defined, this is also not defined. So when the function is not defined for this m less than equal to less than 0, that means it is not continuous. And if you take 0, because it is m less than equal to 0, you have to check for 0 also. If h raised 0 is what? 0 to the power 0. Now 0 to the power 0 is also undefined. There is nothing called 0 to the power 0, infinite to the power infinite like that. This is also not defined. So it is not continuous in either case, m less than equal to 0, m less than 0, or m equal to 0. Okay. Now let us, I'm not cleaning it up because I have to show that how this differentiability will be checked. The differentiability has been asked for first, second, third, all the parts. So we have to check for m greater than 1 also, all these. Okay. Function, see, there are certain things which came as not defined. Please remember, we have already checked the differentiability for the third part. Because of the function is not continuous, it will not be differentiable also. The third part is already been checked, but still we'll do that step. So in the differentiability, we'll take left hand derivative and right hand derivative. This left hand derivative fx minus fc divided by x minus c, that's what we do. Limit x tends to c. Same thing we are going to do here, fx minus fc divided by x minus c. Fx is what? X raised m sine 1 by x. Left hand derivative, we will take x as 0 minus h. Here we will take x as 0 plus h. So x as 0 minus h, x as 0 plus h. X is simply replace it by 0 minus h. Okay. 0 minus h is minus h. 0 plus h is h. Okay. Now wherever x is there, we'll put 0 h minus h and h. So minus h to the power m. I am replacing fx by minus h raised to the power m sine 1 by, since it is negative h, we'll write it negative h. And minus fc, fc is what? C is 0, because we have to check at 0. F0 is what? It is already given in the question, F0 is 0. So you don't have to write this. Don't write minus fc, fc is 0. So I'm not writing it. Okay, we have to write fx minus fc, but fc is 0. It is already given in the question. You don't write it. What is x minus c? It is minus h minus 0, because c is 0. So negative h will be in the denominator. Similarly, on the right hand derivative, h raised to the power m sine 1 by h minus, what is this minus, the value will be fc, which is already given in the 0, which we did in the LHD. So we won't worry about minus something. What is in the denominator? H minus c, which is h minus 0, which is h. Now this minus h to the power 1 it is, and here h to the power 1. Now please remember that when we have the base same and when we have numerator and denominator, when the denominator goes to numerator, it will be subtracted. So a raised m by a raised n, it will be a raised m minus 1, m minus n. So minus h to the power m minus 1 it will be. And here we have sine minus 1 by h. So sine minus theta is minus sine theta. So I am taking minus outside. It will be sine 1 by h. I am trying to make the LHD and RHD same, the way I did it in the continuity. So h raised m minus 1, same thing, sine 1 by h. Okay. Now, since they both are not equal, so I want this negative of the LHD to be combined with the negative outside. Just if we make them equal, we just have to prove it once. So minus h can be written as minus 1 into h. So it is raised to the power n minus 1. So minus 1 to the power n minus 1 into h raised to the power n minus 1 you can write. So this minus 1 to the power 1 was already there. When we take minus 1 to the power m minus 1 outside, the power will be added. So 1 plus m minus 1. So this is 1 gets cancelled. It is minus 1 to the power m. Now minus is vanished here. We have already taken it out. So h raised to the power m minus 1 sine 1 by h. So both the terms are equal now. Now we can discuss for any of the LHD and RHD. First case is when m is differentiable at x equals to 0, when m is greater than 1. So m is greater than 1, what does it mean? H to the power m minus 1 sine 1 by h. What is m minus 1? M is greater than 1. Let us take some value. Let us take m equals 2. The first value is m equals 2. So h raised to minus 1, which is h raised to the power 1 sine 1 by h. Now when we apply the limit h tends to 0. When we apply limit h tends to, everywhere limit h tends to 0 is there, as I indicated to you earlier. When you apply limit h tends to 0, it is going to be 0. And as I discussed in the continuity also, sine theta will always be between negative 1 and 1. 1 and negative 1. Okay. This, whatever you write, whatever you put inside sine, it will always give you negative 1 to 1. When you multiply it by 0, it is going to be 0. 0 is defined. So it is differentiable. Okay. So it is differentiable. Second case. Second case is m between 0 and 1. Now when m is between 0 and 1, same thing we are going, because LHD and RHD, they are equal now. So h raised m minus 1. This we don't have to worry about. Negative is not, you will say that there is a negative raised to the power m, negative 1 raised to the power m, but it will not affect. You'll just see. H, the limit is on h, not m. So h raised m minus 1 sine 1 by h. Now m is between 0 and 1. Just take some value. M you can take it as half, 0.5. When you put h as h raised to the power m, m is half. Half minus 1 is minus half. H to the power minus half is what? It is under root, but denominator under root. X to the power minus 1 is 1 by x. So h raised to the power minus half is 1 by h to the power half. This is 1 by h to the power half sine 1 by h. So when you apply the limit, h is going to be 0. Limit h tends to 0 is always there. Sine 1 by h doesn't matter because it will always be minus 1 and 1 in between. But in the denominator, you'll get just 0. And under root of 0 is 0. 1 by 0 is not defined. 1 by 0 is infinite, undefined. So when it is undefined, the function is not defined, as in the case of continuity. It was continuous, but it is not differentiable because it is 1 by 0. Okay? Now the third case, as I already told you, it is not continuous, so it will not be differentiable. But we'll just check because the question is asking that. So h raised m minus 1 sine 1 by h. That's why I made it LHD and RHD equal. Same way I made LHL and RHL equal, so that we have to just apply it for once to make your work easier. Okay. So we have h raised m minus 1 sine 1 by h. M is less than equal to 0. So when it is less than equal to 0, you have to check for less than also and equal also. Please remember. So h raised to 0 minus 1. I am taking m as 0. So we have h 1 by h. H raised minus 1 is 1 by h. 1 by h is 1 by 0. 1 by 0 is not defined, so it is going to be undefined. The function is not defined. Now let us take less than 0 because equal to 0 I already checked. Now less than 0, that is, let us take minus negative 1 value. So h raised to the power m minus 1. So minus 1, m is minus 1 here. So h raised minus 2 and 1 by h square it is. So sine 1 by h, it doesn't matter because 1 by h square, 1 by 0 square, it is 1 by 0. And 1 by 0 is there, it is not defined. Anything divided by 0 is not defined. Okay? So 1 by 0, whatever you multiply, it is not differentiable. Okay? This is how it is being done. Okay, this is all about this exercise. Thank you so much. Take care of yourself.